Hello and welcome to the second video of this D1 chapter, Algorithms on Graphs. Starter question is an exam question for Kruskal's algorithm. Pause the video now if you've got time and give this a go. The numbers on the 15 arcs, 15, you can see this is going to take a bit of time, in figure 2 represent the distances in kilometers between 9 vertices A through J in the network. Oh no, not quite A through J, we don't have an I in there. Use Kruskal's algorithm to find the minimum spanning tree for the network. You should list the arcs in the order in which you consider them. In each case, state whether or not you are adding the arc to the minimum spanning tree. Then you can see that we're going to have to draw the minimum spanning tree. The one that I sketch as we go won't be the one that will be the final one in an exam, because they are going to give me vertices in the answer booklet, and you should put it on those vertices. Make sure everything goes in its proper place in the exam answer booklet. Finally, we also need to state the weight of the tree. So going for this, I might need 2 columns, there's quite a few here. Going for the lowest weight is the single digit 9, AC. Then we've got an 11, that's BE. You can see listing these out is doing part of what it asks me to do. So it's not just part of the algorithm, it's something that the exam question specifically asks. We've got a 12, that's BF, EF for 14. If you miss one, it's quite likely that you'll see it later on while you're doing the rest of them. You can just slot it into the right place, don't worry too much about that. So long as you do have them all, you're unlikely to put them in the wrong order by the time you've finished going through them. That's all the teens, I think. On to the 20s, we've got E to J for 20. We've got 2 21s. I'm going to do BC first for no particular reason. HJ 21. 23, I would really like to write these all in one long line, but I'm going to run out of space, I think. Yes, there's a 24 as well. Let me put them over here. CD for 25, DE is 28, and then AD is 29. I'm going to quickly count them because I know there should be 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Looks good. We are going to include the first one, of course, and I will just sketch it up here because I don't have the answer booklet to draw it on later anyway. BE, I'm going to add that. That goes down here like this, kind of. BF, no problem. E to F is a cycle, reject. FG is okay. So is FH for 17. I haven't been writing the weights on, never mind. EG, nope, reject that for a cycle. But EJ is okay, that comes along the bottom. That finishes off the right hand side of the graph. BC is okay, that will connect our 2 parts. HJ, nope, reject that. C to E, reject. A to B, reject. Still got one more to get in though. Here it is, CD for 25, yes. We'll take U, put D in, and then DE would make a cycle, and AD would also make a cycle. So reject those 2, and we have finished the tree. If these 3 were below these ones, then I would consider that already showing the order that I've considered them. I've stated whether or not they're adding to the arc by using the ticks and the reject with the cross. I've drawn the minimum spanning tree, although I didn't put it in the right place because I didn't have that on the screen to show you. Last thing I need to do is state the minimum weight of the spanning tree just by adding up all the ones that are ticked. And I make that to be 130. That's Kruskal's. In this video, we're going to look at Prim's, which does the same thing. It's another algorithm used to find a minimum spanning tree, but it does it in a slightly different way. I mentioned one difference in the previous video. Another difference is that while Kruskal's is adding arcs, Prim's is kind of adding vertices instead. So you start with any vertex, add the arc of least weight in order to join another vertex into the tree, obviously one that is not already in the tree. Otherwise you'd end up with cycles. Then repeat step 2 until all the vertices are in the tree. So your focus here is kind of on adding vertices rather than adding arcs. But obviously we're going to do that by adding the arcs in order to get those new vertices into the tree. Again, you have to list the arcs in the order they were added, but you don't have to worry about the arcs that you don't want. Whereas Kruskal's, you're listing all of the arcs. So I'm going to do the same two examples as the previous video, but use prims instead. Here, let's start with any one. Often A is a good one to start with. So I'm starting with A, and the idea is I need to add another vertex from A, specifically from A. I've only got two options, either the 7 arc that goes across to B, or the 8 arc that goes down to E. Out of those two, 7 is the smaller option. So I'm going to add arc AB. Now I need to add another vertex in by putting another arc in. And I can still choose A, but I'm not going to because that's still an 8. In this graph, that's the biggest one, so I'll never end up choosing that. But I must consider all of the vertices in the graph so far, not just try and connect from the last one that I added. So I do consider 8, and I consider the 5 here and the 5 here. As with cruscles, when you've got two the same, choose whichever one you like. So I'll choose C for 5, so I'm adding BC. Then, from A, B, and C, I need to consider all the arcs that will get me a new vertex. Again, I've got the 8 here, I've got a 5 here, and I've got a 2 here, and a 3 here. Out of all of those, 2 is the next one that I can add that will get me a new vertex into the graph with the smallest possible weight from one that's already in the graph. Then I keep going, I do the same thing. I don't consider this because that will not get me a new vertex into the graph. I do consider this, that would get me E, so would this, so would this. Out of these three options, the 3 is the best one. Oh dear, I haven't been keeping track. So this one for 3 is the one that I add in, and that is CE. So this is what the examiner needs to see, the order that you've added the arcs. That tells him or her that you've done it in the correct order, i.e. you've applied the algorithm in the correct way. Second example, again, same one as before with cruscles, but this time using prims. We know this is going to apply in a different way, because before we had the 2 here jumping straight over to the 2 here, and prims will never do that. It will always grow as a connected tree. I'm going to start with A again though, so it's not going to start with a 2 at all. I'm going to start here. To get another vertex into my tree, I've got a 3, a 4, or a 3. 2 3s are the same, I can choose whichever one I want. I'm going to start with F for no particular reason. So I've got A to F for 3. Now I can connect in G with 5, E with 5, G with a 4, or B with a 3. I don't have a choice anymore, it must be the B with a 3. So for this one, if this were in an exam situation, the examiner would have to see these two first, although it wouldn't matter which order. In the mark scheme, it might write them one above the other like this, AF, AB, and then a comma, indicating that it doesn't matter which order they go in, so long as they are both before any other arcs. From here, connecting from F, I could do a 5, from A I could do a 4, from B I can do a 5 or a 2. Now that 2 is obviously the best choice, and it does get me a vertex that's not already in the graph, i.e. no cycle. I strongly recommend you track your arcs as you go, because if you do the tree and then go back and think, oh, which one came first, you might have too many arcs to remember the order you chose them. Looking at B, there's a 5. Looking at G, I've got 7, 4, 3. 3 is the best one here, so I can connect in here G to E and get E into my tree for 3 instead of the 5 here. Now I've got E, I can get D into my tree for 2, which is clearly the smallest one left in my graph. Now I need C into my tree, and the best way to do that is to go from B to C. I've done just exactly what I said not to do. B to G, and then G to E, and then E to D. Keep track as you go. Don't do what I did, do what I said. C for 5, B, C. There we go. And if you compare that with the answer we got in the previous video, I hope that you will see it is the same minimum spanning tree. Even though there can sometimes be more than one, in this example there is only one answer, and this is it. That should be enough for you to have a go at questions in exercise 3b, and maybe I'll see you to apply this same algorithm on a distance matrix in the next video.